In this second video, we will use dictionaries to find the closest grid point to a structural framing start or end point. The idea is to create a dictionary with the grid lines names and the point as a keys and the point intersection point as a value, and then find the closest point to the closest grid points to the beam start point, and then to retrieve the grid lines names. So let's start constructing the finding the intersection points and constructing the grid intersection points and the dictionary. So it's easier if we keep the verticals and horizontal grids separate. We then, once we have selected the grids and we check that only grids have been selected, we can go into Revit Elements and grids and extract their underlying curves. We can then use the find intersection or find intersection node from Launchbox. That will give us all the points. And then if we go to Revit Elements, element names, get the vertical and horizontal grid lines name. Okay, so we can create a dictionary by keys and values. Let's flatten this intersection points list, and these points will be the values. And let's now construct the keys, which will be a combination of vertical and horizontal. We need to do cross products and check. Be sure that the list structure matches the one of the intersection points. So let's add an hyphen between the grids, and see now they have changed. So let's swap and have them like this and flatten. So we have them in a dictionary. It doesn't matter if they are not in order, in the order that we specified, but because we will use just the distance. So in order to extract keys or values, we can use this dictionary.components node. And then let's now find the beam start and end points. So select the beam, go to Revit, Elements, Structural Framing and Location to extract the curve, and then we can use end point or start point. Now we need to pay attention to the Z values of these points, because grid lines are placed on a XY plane that has a 0 elevation, while the our structural framing can be at different elevation. So we could project or pull the curve, structural framing curve, to a XY plane with elevation 0 before using the geometry distance node. So we want to find all the distances, and the minimum distance will be the closest point. We can see that in this case, item 14, which is C1, is the closest point. Let's now see how we can extract this index automatically. The way we can do it is using list, organize, sort index by value, which will sort this list by the minimum distance, minimum values. We can then extract this value, and then we want to take the keys at index 14. Now, if we use get item at index and we have these keys, this will work. What if we want to now find both start and end points closest to grid lines intersection? We can store the 2 points into another dictionary. So if we want to store 2 values, 2 points, we need to use list create first, and then connect it to the values, and then as a key we could use the beam mark parameter, which in our case is beam 01. So keys, values. If we leave everything as it is, the beam will be associated with just the first point. And even if we change the lacing, it will create 2 dictionaries. Instead, what we could do is change the levels to 3. And in this case, we will have just 1 key for 2 values. We can then again extract the component and the values and we need to flatten first because the list structure now is quite messy, so we will need to do cross product, but then it's not working. So let's flatten first. Now we are in the same situation as before with only have two lists instead of one. We sort them. Instead of extracting the first item, we can use a get item at index with a lacing set to longest. And this will give us the two values. So if we move our beam to A7 endpoint, C5 start point, C5, A7. Okay, so what if we have two beams now? So let's create another beam here and let's call it beam 02, and then go back and select both of them. So if we run the script, we will still have the output. First of all, it will be easier to split the output in two. And the other thing that we should note is that now we get the start points in one list and the end points in another list, instead of having start and end points for each beam. We can fix this by using a transpose into the start and end points. This is because the list we create is a list of start points and end points, while we want to have start and end point for each beam. So now the beam 01 starts at C5 and ends A7, and the other one starts at C2 and B3. Let's add a new beam. Let's call it beam 03. So this will start A4 and end at B5. If we run the script, we need to select first. See that the order of our beams has changed. So now the last one that we have created is at the beginning of the list. So if we want to write these values into a parameter, let's do, for example, let's write that into the comments. Let's combine these two values. So we can use deconstruct, set it to longest, and then again, as we did before, we can create a string like this. So these will be the values. And in order, so we could just connect the elements there and check. And as you can see, these are different because these are wrong because when we create a dictionary, the dictionary just changes the order of the element that we have selected. So we can again create another dictionary with the beams as the values, the names of the beam as the key. See, we had 1, 2, and 3, and here is 3, 1, and 2. So once we have this dictionary, we can then use value at key with the keys coming from the other dictionary, and we will always be sure that the order is the same. Now, because these values comes with a nested list, we just need to flatten. So C2 and B3, A4 and B5, C5 and A7, and if we move them and rerun the script, or if we add a new beam, and let's call it beam 04, and then we need to select and run. See, number 4 now is in the second position, but if we check in here, these values are correct.